So I'm going to give you a lesson in two parts today. We're going to look at a factor of safety, which is another element that we're going to add to structures. So I'll give you a link to these pages. You definitely need to look at these pages here, and I'll give you a link to that. So that's entitled Factor of Safety page 2. You're only seeing half of my page just now. That doesn't matter, because you guys are perfectly capable of reading through. That is about 4 pages to read, and then we're on to the questions. Okay, but that's what the top of page number 2 looks like. You also need to have this here, which is the data book, and I really recommend that you print it out if you can. And we're only going to worry about one page in it, which is this page here. Now, here we go. So let's look at the top of that first of all. Most of these formulae we've used before. We're probably not going to use elastic strain energy, but we're going to use stress strain, Young's modulus, and a new thing which is called factor of safety. We'll get onto that in a minute. The second thing that we're going to definitely use is this table down here, which gives you various materials, and for each of them it gives you Young's, the yield stress, which is the stress in which it bends and doesn't go back. In other words, it's into the plastic, it's in its plastic state. So below that is the elastic limit. Then you've got the ultimate tensile stress. That's when it's going to break, when it's getting stretched. Okay, and then the ultimate compressive stress, and that's when it's going to break, when it's getting compressed. So we need all those factors. Right, okay, so that's the material that we're going to be using. You could simply read it and see how we're going to use it. In this little lesson, I'm going to talk about the theory behind factor of safety. Okay, so I'll get my jotter. So factor of safety, there's an easy and obvious way to do it, to talk about factor of safety. So for example, let's say we have a wire with a weight hanging from it, okay, and the client knows that weight is going to be, let's say, 10 newtons. Okay, so that weight's 10 newtons, and the wire's got to support that. It would be ridiculous if we designed that wire so that it holds 10 newtons, because a flock of birds landing on it, a windy day, or just a rubbish bit of metal is going to break. So what we can do is apply a factor of safety. Put simply, if we apply a factor of safety of 5, we would design it to hold 50 newtons. Okay, 50 newtons, and that there would mean that would have a factor of safety of a factor of safety of 5. Okay, so just use the terms that are in the data book. That the safe working load is 10 newtons, but the ultimate load, the load that you're designing it for, is 50 newtons, and anything beyond that could break. Okay, now in the exam it might ask you why a factor of safety is applied, and you could say something like because if that breaks, it's going to cause a lot of damage, or if that breaks, it could injure someone. So a factor of safety of 5 is reasonable. But let's say it asks you the question, an engineer applies a factor of safety of let's say 400, and that was in one of the exams. The factor of safety was 400. So you could say, quite legitimately, you could say that engineer that designed the factor of safety of 400 was taking great care that it would never break. Equally, you could say that engineer has wasted a lot of money, because a factor of safety of 400 is ridiculous. Okay, so that is the kind of questions you get asked, and that is the easy way to apply a factor of safety. Let's look at the other way of applying a factor of safety. So let's say again that we've got a wire, okay, and this time we're I don't think it's very important how much it weighs, but we'll put in the same amount of 10 newtons, okay. So let's say that we know for a fact that they're going to use steel for this for this wire here. So they're going to use mild steel. So if I look here on the mild steel, I can see that mild steel will break at this point here, okay, 430. So what I would do here is the working stress, sorry, the ultimate tensile stress of this steel is going to be 430 newtons per millimeter squared, okay. If I was to apply a factor of safety of that to that, so I'll apply a factor of safety of 5, so I'm going to say a factor of safety equals 5. What I would do this time to find out the safe working stress of it, so safe working stress, I would take the ultimate stress, in other words that's where it's going to break, and divide that by 5. Okay, and divide that by 5. Now you could see there in one of them we're multiplying by 5, and one of them we're multiplying by 5 to give us 50 newtons. In this one here we're dividing by 5. It's dead easy to get it mixed up. It's very easy to get it mixed up, and in fact I've seen pupils doing both of these, so they end up with a factor of safety of 25. So you've got to be very aware of what you're doing when you start out on this, okay. Now in our next lesson, what I'll do is I will do one of the calculations that you're going to do, and all that you need to do in the assignment for whatever question I decide to do, you can simply copy that for that number. Okay, right, see you in the next lesson.